right, strap in, everyone. Today we're going deep on something that's both fascinating and a little bit unnerving: asteroids.
Oh yeah, always a fun topic.
Specifically, we're diving into all things Apophis. And to help us out, we've got some awesome info from the Planetary Society.
Very resource.
For those not familiar, they're all about space exploration and planetary defense.
Which, as you can imagine, is pretty crucial when you're talking about asteroids.
No kidding. So Apophis, right. Even the name, it's like taken straight from an Egyptian god of chaos.
Right.
I mean, come on. And Hollywood doesn't help. Every asteroid movie, it's like instant planet killer.
Yeah, I know what you mean.
So, real talk. How worried should we be about this Apophis thing?
Well, it definitely got people's attention when it was first spotted back in 2004. Early calculations, they were suggesting like a small chance.
A small chance of it. Don't leave me hanging.
Small chance of it actually hitting Earth in 2029.
Okay.
Yeah.
Yeah, I'd be sweating a bit too.
Thankfully, though, more recent data, with scientists constantly watching it and refining their models.
Refining, like getting more precise.
Exactly. So the newer data completely rules out any impact in 2029. And 2036, too, for that matter.
Okay, so no need to build a bunker just yet. But it sounds like this isn't just some random space debris we're talking about.
Definitely not. Even though it won't hit us, get this, April 13th, 2029.
Friday the 13th. Oh, that's just perfect.
Right. Well, on that day, Apophis is going to come super close to Earth. Closer than some of our satellites, even.
Hold up. Closer than the satellites that, run our GPS and communications and stuff?
The geostationary ones, yeah. It's wild. Those orbit at, 35,786 kilometers up,
Yeah.
always staying above the same spot on Earth.
So to have an asteroid buzzing closer than that, I mean, how big are we talking?
Apophis, it's about 450 meters across.
Meters. Okay. Put that in terms I can actually picture.
Yeah, so picture 5 football fields laid end to end.
All right, that's big.
And taller than the Empire State Building, too.
Okay, that's officially a serious chunk of space rock. Do we at least know what it looks like? Or is this a total mystery blob?
Well, we've got some clues from radar. It could be egg-shaped.
Like literally an egg.
Could be. Or, another possibility, it might have this dual-lobed structure.
Dual-lobed? Like two bumps stuck together.
Yeah, kind of like that snowman shape we saw with Arrokoth, that object New Horizons flew by.
Right, right. Okay, so maybe not the prettiest thing in space, but hey, at least it's not hitting us. But, just for fun, let's play out that what-if for a sec. If Apophis DID hit, what kind of damage are we talking about?
So, full disclosure, it wouldn't be a dinosaur-killing global extinction event. That asteroid was way bigger.
Well, that's a relief.
But still, if Apophis hit, it would be catastrophic, no question. Widespread destruction for hundreds of kilometers around the impact zone. The energy released would be equivalent to over 1,000 megatons of TNT.
Yeah, on second thought, I'm good with it just buzzing by. But 2029, that's not exactly tomorrow. So what's happening with Apophis between now and then? Just cruising along, I guess.
Well, it'll be making its way towards us, obviously.
Yeah.
But get this, on the night of that close approach, April 13th,
Friday the 13th, right. Never going to forget that.
if you're in the right spot, Europe, Africa, Western Asia, you might actually be able to see Apophis in the sky.
Wait, seriously? Like with the naked eye?
Yep. It'll look like a bright star moving pretty quickly across the sky.
Now that is something I gotta see, and I hear NASA isn't just gonna, sit back and watch.
Oh, definitely not. They've got the OSIRIS-APEX mission all set.
OSIRIS-APEX. Catchy name. Tell me more.
So it's a spacecraft, actually originally for a different mission, but they repurposed it. It's going to rendezvous with Apophis in April 2029, right before the close approach.
Oh, so right up in its face.
Pretty much. And then it will spend about 18 months just studying the asteroid up close.
That's awesome. So what are they hoping to learn by, getting all cozy with Apophis?
Lots of things. They'll be looking at how Earth's gravity affects its spin, its surface, all that. It'll tell us about its internal structure, what it's made of.
Right. Makes sense.
And that's not just for understanding Apophis itself. It helps us figure out how to maybe deflect asteroids in the future, if we ever needed to.
Deflect. Actually push them out of the way.
Exactly. It's all part of what we call planetary defense.
Planetary defense.
It
sounds like something straight out of Star Wars. But I'm guessing this is serious stuff.
It is. So the question is, could we actually stop an asteroid like Apophis if it was headed for Earth?
Now that is the million-dollar question. And I think we need to dive into that right after a quick break.
So before the break, we were talking about, actually stopping an asteroid.
Yeah, full-on Armageddon avoidance.
Right. And, it may sound like sci-fi, this whole asteroid deflection thing.
It kind of does.
But the ideas behind it, they're rooted in real physics, real engineering. And scientists have come up with a few different methods, each with its own pros and cons.
Okay, so, like, what are the options on the table? If we see a big rock headed our way, what's the plan?
Well, one of the more straightforward ones. It's called a kinetic impactor.
Kinetic impactor. Sounds intense.
It's pretty much what it sounds like.
Yeah.
You slam a spacecraft into the asteroid fast to knock it off course.
Like a cosmic billiard shot.
Exactly. The impact, it transfers some of the spacecraft's momentum to the asteroid, just a little change in its direction.
Makes sense. But what if it's a really huge GE asteroid? Like way bigger than Apophis? Would that still work?
For those situations, they're looking at other stuff. One that gets a lot of attention and a lot of debate too, it involves using a nuclear explosive.
Hold on. Nukes in space. Isn't that a bit, extreme?
I hear you. It's not a decision anyone would take lightly, but the idea isn't to blow the asteroid up, like in the movies.
Okay, good.
It's more about a controlled explosion near the asteroid to vaporize a bit of its surface.
And that would.
Create this powerful jet of material, basically pushing the asteroid away from its original path.
Like a rocket engine, but using the asteroid itself as fuel.
Precisely. Of course, using nukes in space is complicated, to say the least. There are treaties, environmental concerns, a whole thing.
Yeah, that's not something you just whip out lightly.
But it is one of the options scientists are studying.
Okay, so what about non-nuclear options? Anything a little less explosive?
There is. One really cool concept is the gravity tractor.
A gravity tractor. That sounds almost gentle.
It kind of is. The idea is you use a spacecraft's own gravity.
A spacecraft's gravity. Isn't gravity pretty weak?
It is, compared to, like,
Yeah.
an explosion, yeah. But the gravity tractor wouldn't be a sudden push. It'd be super slow and gradual. You put a spacecraft near the asteroid, and over years, maybe decades, its gravity pulls on the asteroid just slightly.
So it's like a long, slow tugboat.
Exactly. And a big advantage is that it's very precise, predictable. No explosions to worry about, just using basic physics to guide the asteroid away.
Pretty clever. Anything else scientists are working on? Or are those the main contenders?
There are a few more speculative ideas out there, like you could attach a big solar sail to the asteroid.
A solar sail, like a giant mirror.
Yeah, and use the pressure of sunlight to slowly change its orbit. Or even, this is wild, paint the asteroid a different color.
Paint it? What good would that do?
It changes how much sunlight it reflects, which can actually affect its path a little bit. These are more like out there ideas.
Yeah, those are definitely outside the box.
But it shows you how scientists are thinking about this problem, They're getting creative.
It's cool to see how much effort is going into this. We're not just helpless if a rogue asteroid decides to pay us a visit.
Exactly. It's a testament to, human ingenuity and problem solving. And it's important to remember, the threat's real, but it's not a reason to panic. Smart people are on it.
That's good to know. Speaking of learning about asteroids, you mentioned earlier that NASA's OSIRIS-REx mission brought back a sample from an asteroid, right?
Oh, yeah. OSIRIS-REx, that was huge. They actually collected samples from Bennu.
Bennu, another asteroid.
Yeah, a near-Earth one, and also classified as potentially hazardous.
So they brought back pieces of a potentially dangerous asteroid. Seems a bit risky.
I get what you mean, but studying these samples up close, in labs here on Earth, it lets scientists really understand Bennu's composition, its history.
Ah, so like know your enemy.
Not exactly enemies, but yeah, the analogy works. The more we know about asteroids, the better we can protect ourselves. It's all about knowledge and being prepared.
Okay, that makes sense. But, I'm curious about the specifics. How do we actually go from these ideas, these deflection methods, to actually doing it? Like the calculations, the planning, all that.
Great question. So let's get into the nitty-gritty of the physics behind asteroid deflection.
Let's do it. And thankfully, we have plenty of time to unpack all that right after a quick break. All right, welcome back to the show. Before the break, we were talking about how to actually deflect an asteroid. We've gone over the what, now it's time for the how.
Right. It all comes down to physics.
Leave me with it.
Well, a lot of these deflection methods, they rely on this concept called momentum.
Momentum. That's like how much oomph something has, right?
Yeah, basically. It's an object's mass times its velocity. So, like, think of a bowling ball.
Okay, I'm picturing it.
If it's rolling slow, it's got less momentum than if it's zipping down the lane super fast.
Yeah, that makes sense. But we're talking about asteroids, not bowling.
Right. But same principle applies. Asteroids, they've got huge mass and they're moving ridiculously fast.
So their momentum is, like, off the charts.
Exactly. And even a small change in that velocity Over time, it can move the asteroid a long way off its original path.
So that's the goal, to tweak their speed or direction just enough.
Exactly. And that's where our deflection methods come in, like that kinetic impact we talked about.
Right, the whole ramming a spacecraft into it thing.
Yep. That impact, it transfers some of the spacecraft's momentum to the asteroid, giving it that little nudge.
So, like, we're using a spacecraft as a cosmic cue stick.
Pretty much. And just like in pool, the angle of the impact, how fast the spacecraft is going, all that matters. Scientists would calculate all that very precisely to get the asteroid to move the way they want it to.
Okay, that's the impactor. But what about the other methods, like the gravity tractor or even the nuclear option? Those aren't about crashing into anything.
Right. They work a bit differently. The gravity tractor, as the name suggests, it uses gravity.
But isn't a spacecraft's gravity pretty weak?
Compared to an asteroid, yeah. But here's the thing. The gravity tractor, it's not a sudden push. It's super gradual. You park a spacecraft near the asteroid, and over a long time, its gravity just tugs on the asteroid little by little.
So it's a slow and steady approach.
Exactly. And one of the big advantages is it's very precise, very predictable. You're not relying on an explosion. You're using physics to gently guide the asteroid away.
Very elegant. I like it. All right, what about the nuclear option? We kind of touched on that earlier, but how does that actually work physics-wise?
So, as I said before, it's not about blowing the asteroid to pieces like in the movies.
Good, because that would probably make things worse.
Right. What you do is you detonate a nuclear device a certain distance from the asteroid. The explosion, it vaporizes a chunk of the asteroid's surface. Creates this huge jet of superheated material shooting out into space. And that jet, it acts like a rocket engine, pushing the asteroid in the opposite direction.
Ah, so it's using the asteroid's own material to kind of steer it.
Exactly. But again, using nukes in space is a whole other can of worms, politically and ethically.
Yeah, definitely a last resort. But hey, it's pretty amazing that we've even come up with these ideas, right?
It is. It shows how far we've come in understanding not just asteroids, but space in general. And it's important to remember that threat from asteroids, it's real. But we're not just sitting ducks. We've got smart people working on solutions.
And thanks to the Planetary Society, we've got a better understanding of those solutions. Be sure to check out their website, everyone, for even more info on all things space.
Definitely worth a look.
And with that, I think it's time to wrap up this deep dive. It's been fascinating, a little scary at times, but ultimately I think it's pretty hopeful. We're not alone in this universe, and we're learning how to navigate its challenges.
Couldn't have said it better myself.
Until next time, everyone, keep looking up and keep asking questions.